Hey all, it's Andrew Couch here, and in this Tidy Tuesday video, we're going to be going over the Purrr package. So this is going to be the final installment of my Intro to the Tidyverse series, and I consider Purrr to be the more advanced package from the Tidyverse because it basically relies on functions and functional programming. So if you don't have a good understanding or a good amount of experience with functions in R, you might want to check out my video on functions. Um, but for this video, I'm probably gonna go pretty beginner friendly with what I'm gonna do with Purrr, just so you guys can get a basic understanding of what we can do with it. Um, Recently, I've noticed that I've had some audio issues in my past videos. I'm not really sure why because I just use OBS and it's mostly plug and play. I don't also change anything. So I went back to my OBS settings and basically just converted them to default settings. So hopefully the audio issue was solved. I'm not really sure what was going on because I don't really change OBS. Not only that, but I haven't really been on my desktop for a few weeks. So hopefully that'll fix everything, but we'll see. So I'm going to open up my season 2 project, and we're going to load in an R markdown document, and I'm going to call this like a brief overview of Purrr. I'm also going to basically go over the main functions of Purrr, but with Purrr itself, there aren't a lot of functions that goes actually into it. So if we go to the reference, we can see it basically goes around the mapping function. So the map function, we have a lot of variants. So we have map2 LGL, or logical, map2 int. But what map really is just a for loop. So if we want to iterate through a list or a data frame, we can use the mapping function to basically be a nice little helper function for your traditional for loops. I never use for loops in R anymore. I always go with mapping, which is the more tidier way to do it. But I think if you're doing a lot of development for packages, you might still stick with the for loops. With the actual map families, you can see how with map, you have map logical, character, int. These things are basically saying what we want to, we're specifying what we actually want to return. So with map, that's your overall, like you don't really want to, you're not specifying what you're returning. So it could be a data frame, a number, a character, a chart, whatever. But if you want to be more specific, so you don't have to do any cleaning, you can say like map integer if you're going to return like a number, or map double if you know you're going to return a double. Map DFR and map DFC are data frames, and you're basically just saying whether it's a row or a column. And then we have our map variants, which are map2 and pmap. I don't really use imap at all or lmap, but I mostly use map2 or pmap. And although they seem a little bit more confusing or a little bit more advanced, it's just passing in another argument. So with map2, we're passing in 2 arguments. With pmap, we're passing in multiple arguments. So we can use as many arguments as we want. But we'll go over that right now. Okay, so with the tidyverse, when we load in the tidyverse, we already have the Purrr package. And generally when I was first learning Purrr, I didn't really understand when to use Purrr, right? So with Purrr, I just would always assume I would use a mutate instead of a mapping function, because if we're going to go through an entire list and do some type of transformation, it doesn't really make any sense to use Purrr or to use map over mutate, right? So if I wanted to say I want to take the square root of sepal length, I'll just say square root sepal length is equal to sepal dot length, and we're just going to do a basic square root, and that does it. That essentially went through the entire list and returned the square root of the value. One of the things that we have to realize, though, is that the square root function is vectorized, so it can actually pass through a vector, whereas with map, it doesn't need to be vectorized. But if we want to do the same thing, so we can say map square root, we can just pass in the map function, map, and in this case, we're basically saying that we have a data frame, and we're going to pass a column as a list. So let's say sepal length. And then what we need to do is call in the function, which would be square roots. And we can see we have this little double. And if we look at right here, we can see that it actually returned a list. So with Purrr, it's always going to return a list. But luckily, we can do a few things. For one thing, I can always say unnest, and it'll just basically unlist the values. But since we know that we're doing a square root, we can also say map dbl, and it'll pass in, it'll just automatically unnest and pass in that single value. There's a few issues you might run into with Purrr. So one thing that you might run into is you might have multiple lengths of a list. So if we just do this, we might see sometimes where we'll have like 2 items in this list, and that will be something where you have to basically adjust the function or be able to just unnest it and understand that you might have some repeats. What's also kind of interesting is, let me see, is that we can actually pass in multiple arguments with our mapping function. So in this case, we can say map, right? So we can pass in this. Oops. So we have that. In this case, I'll probably just do log. And with log, we have these other arguments with base exp1. I think we can say like log, let's say 10 base is equal to like 3, right? So in that case, we can say a map and a log, and we can just type in base is equal to 3, and it'll pass in that function's second argument. So there are many ways we can actually pass in arguments using map. I would advise I would try to use the simpler mapping function. So when I mean simpler, I mean instead of using map2, where in this case, if I were to want to pass in a base 3, I would say like mutate base is equal to 3. And then I would say mutate map square root is equal to map 2. And with map 2, we can see we have a .x and .y. And that is essentially our first and second inputs, and then our function. So in this case, we'd say sepal.length, base, and then we could say like log. And if we do map2 dbl, we can see we have the same thing, right? As you can see, this is still kind of confusing because at the end of the day, we probably wouldn't be doing it like this. Additionally, it's going to be a little bit slower because essentially we're going to go through, the list, and it's not vectorized. So what we can think about is, what are the actual use cases for map? One of the things that I like to show people is combining it with its other functions from the tidyverse. So I mentioned in my other tidyverse videos is we actually have a nest function, which is part of the tidyr package. What we can do though is essentially nest everything by species. So in this case, we're creating 3 data frames where each data frame represents the species data. And what we can do is we can pass in this data, since this data is a list, into a function. One of the things that we can think about is creating like a bunch of models. So this is probably a pretty simple approach, but we can say we want to make a model, and it is equal to map data. And then we have to pass a function. In this case, we can say we can use a tilde, or we can type in .f is equal to function, and then give it our little argument. Or we can just write a function, and that'll just automatically do it. So we can do this. We'll just do it all 3 ways. So in this case, I'll just say, we'll do the first quick way in case we're having a simpler function. So in this case, it'll be like that. We can say like, we'll just predict, I don't know, sepal length. Sure, yeah, sepal length using sepal.width, width plus petal.length plus petal width. And then we have to pass in our data, which is equal to .x. Right? So what we basically did was we created 3 models for each species, right? Um, and now what we can actually do is I'm actually loading another helpful package, which is the Broom package, which allows us to basically tidy these models. So let's select the species and model. And if we actually unnest these models, since this is a S3 like LM object, we can see that it gets a little weird because it says the input must be a list of vectors. Because we can't really return all these models because it's not the right class that we want. There are a lot of ways we can do this. So we can say like, maybe we'll like pull the model or something like that. And we can see how, okay, we have these three summaries of our linear models, but that's not really clean. We can't really do anything with it. We can't plot it out. And it's kind of hard to see because you can see how it's in a list right now. Luckily, we have the Broom package. And what we can do is we can actually do another mapping function. And this is where we know that, it kind of doesn't make any sense that we'd pass in our model from a mutate. It just wouldn't work. So if we say model equals tidy model, we can see that there's no tidy method recognized for this list, right? So we'd have to like extract that model from the data frame. So what we'd have to do is like we'd have to select this model, put it into our tidy function, and then extract the actual results. And if you think about that, we're essentially wanting to go through the list sequentially or just like one by one, pass that model into a function, and then return our coefficients and our summary statistics of the model. So when we think of stuff where we know we can't really use mutate because we're going to be passing in a lot of information and also returning a lot of information, we want to think about using map. So in this case, we can say is model is equal to, or we'll just call it tidied model or tidy model is equal to map. And we want to pass each model into our tidy function. And there we go. We have a tidy model as a tibble. And in this case, we can just select our, we'll just select our species and our tidy model. And now we can actually do is unnest it. And as you can see here, we have all of our coefficients, we have our terms, estimates, p-values. Probably would need to do some analysis. We could do some analysis from there. So we could say like ggplot y equals estimate color is equal to species. And then we can just say like a GM point, right? And we can see how these coefficients kind of change with our actual species. And that's pretty useful for a lot of our stuff. Additionally, what we can do is do some actual like we can show how we tidy models actually uses mapping, which I actually find pretty useful. So generally when we're creating a bunch of models, or for me, I'm creating a lot of forecasts, I want to manage a lot of models, but I also have to manage a lot of parameters. And with forecasts, we're always going to be like refitting the data so we can forecast the next period. And when you're managing a lot of forecasts, you need to kind of manage a lot of parameters. So often what I'll do is I'll create a grid of parameters for each model. So let's actually go through here and make, some type of nested model, which like with like XGBoost or something like that. So we'll do that. Okay, so we have our data right now. And what we want to do basically is we want to train, let's just say, a random forest model for each species. Right. So obviously right now, like it maybe won't make too much sense to do it for species, but you can see if you're, doing a lot of forecasting with like a lot of product data or a lot of, just a lot of like time series data, where that you need to have an individual forecast for all that stuff. This will be essentially what we would try to start approaching. Right. So we have our nested data. What we would probably want to do is create our testing splits. So I'll create my seed, which would be 54. And then what I'll do is like, we'll create our data splits, and we'll just map our data and say initial split. In this case, we could say prop is equal to 0.8, and we have our splits. And then what we would want to probably do is our train data. So map data splits, and we'll say training. And then we'll say our test data is map data split is testing. And then we could finally create our final, um, uh, we can now start thinking about how we want to create our models. So in this case, we actually might want to try to create just a general model for all of our stuff. So what we can actually pass in is a model. So in this case, we'll do we'll say our model is equal to not even boosted tree, or we'll do a random forest, right? Random forest, and we'll say trees is equal to tune. Oops, must be a vector, and then we'll just like oh, actually, I have a better idea. We'll do that, and this will be our model data, right? And then what we want to do is start creating our models that we want to tune. So in this case, we'll do a RF model, so random forest. In this case, we want to set our trees to tune. Probably just going to do a regression problem, and then we'll say set engine to random forest, right? And now we want to do is create a grid. So our RF grid is a grid regular, and we'll give it our regular, and we'll give it our random forest models parameters. Parameters. And we have our RF grid. And then that's basically it. We'll also have to start creating a recipe. So we'll start doing that right here. So let's actually create our recipe. So in this case, we'll say mutate recipe is equal to map train data. And in this case, we'll do the different way to create a function in our map. So we'll just do the .f is equal to function x. In this case, x will be kind of a proxy for our train data. And we'll say recipe. We'll say sepal dot length data is equal to x. Right. So we're not doing any pre-processing. We're basically saying what our variable we want to predict with. What we want to predict and what we want to predict with, which in this case, we're using all of the data besides species to predict sepal length. Right, so we have a recipe. And one thing I also forgot was we need to get like our little k-folds data set. So I'll just say k-folds data is equal to map, and we always pass in our train data, and we'll just say bfold cv, and we can pass that right there. So, oops. So we'll just say create k-folds and recipe. Okay. So now that we have our model data, we kind of want to pass in our training stuff, right? In this case, what we want to think about is we'll say train models, and we have to think about what we want to pass. So in this case, we're going to be passing in our recipe and our k-folds data set. The rest of the stuff, we're actually just we already have our model grid, so we'll just fit to that. Okay. In this case, we'll say tune grid. We give it our model, which is right here, our RF model. We give it our recipe. We give it our grid, which will be our RF grid. And we'll give it also our resample, so that way it can tune our parameters with our k-folds data. Okay, and we have that right there. And now, now what we can do is we can pass in our model data, and we can say what we're going to do is essentially get our tune results. So tune result is equal to map2, and we're going to be passing in our recipe, which will be right there, and our k-folds data, and we're just going to say train models. And now what we're doing is basically training all of our models with one simple step, right? And if we look right here, we can see how Purrr is actually pretty useful because it makes everything look very clean. It also encourages us to write our transformations and all of our processes into a function and name it something, convenient or informative. Instead of having that, what I think is kind of a not really a great looking syntax with for loops. So it'd be like for um, I in like 1 through 3, and going through that and specifying all that. We can just use this little map right there. I'll do it for us. Okay. So we have our model data. In this case, we will say, our parameters is equal to map tune results, and we say show best RMSE n equals 1. Right. Right. So now we have our parameters right there. Okay. Now that we have our parameters, what we can do is we can actually finalize our model. So we'll say final model is equal to dot map parameters, and in this case we're going to pass it into a function, right? And what I'll say is we'll have our we're going to basically pass in a workflow. So our workflow will be our model and actually we'll pass in 2, which will be our parameters and our recipe. So we'll just pass in X and Y, and then we'll say workflow, add model, which will be our RF model, add recipe, which will be our recipe, and we'll say finalize workflow and pass in our parameters. Right. Oops.f equals function. Map to. Oh, yeah. It's RF model X, add recipe is Y. F equals, okay. Unexpected symbol. Map to RF model XY finalize. Oops, it's here. So we got that, and we'll say mutate final model is model equals map to, and we'll give it our parameters, and then our recipe. F is equal to function XY. And then workflow. Add model, which will be our RF model, add recipe, be our Y, and then finalize workflow, which will be our Y. There we go. Lastly, what we want to do is we want to do, our last fit. So we'll say eval is equal to map to final model data splits, and we can say I think we say last split, final or last split. Is it last split? Oops, parsnip. Was it last fit? Yep, there we go. In this case, we'll pass in there. Last fit. Yep. Oh, and then we have a little period. Cannot calm trees. Uh-oh. Oh, that's why. And then our parameters is okay. And with our final model data, what we can do is we'll select our species and our eval. Oh, species and eval. And then what we can say is mutate metrics and then map eval collect metrics. And then we can select our we can select our species and our metrics, and we can unnest those final metrics. Oops. Okay. And as you can see, we have pretty good room mean squared error. We predict a little bit better on Virginica. Cool. So that's basically it for general using Purrr with tidy models. But we'll actually go into maybe some charts that we want to do. What I also enjoy doing with Purrr is mapping out some charts. So what we can do, right, is we can nest minus species, and then we can say, like, I don't know, we can just plot out a scatter plot. So map a data dot f is equal to function x, ggplot data equals x, aesthetic is equal to sepal dot length y equals sepal dot width, and we can say like I don't know, like a GM point, right? So we can return a ggplot object, and then we can say like unnest. I think it's unnest chart, or is it pull chart? Yeah, we can pull the chart, and we can see each we can see all three of these charts pretty quickly. So again, when we think about this, we can kind of get creative with it, where not only not only can we train a lot of models, but we can basically automate and do a lot of things in a quick succession. So if I had like a huge report that I wanted to do for like each manager, and I had like their manager IDs with their respective data that they have to track, maybe it might be worth it for me to write out a small little function to plot out the general charts that they want to see, or maybe like a table that I would want to write out. So that's basically it for mapping. Mapping in general, we're basically just wrapping around functions that we think that would be useful to go through iteratively instead of a vector. And basically the good way to think about it is, if you don't know if you don't know whether to use map or mutate, try out mapping first. If you wrote out the function, and if it gets good results, then try to pass it into mutate. And then if it doesn't work in mutate, you can probably rewrite the function until it'll be vectorized and it'll work through mutate. But sometimes we run into some issues where map will return an error. In this case, a lot of the times I use a mapping is with web scraping. So if I go to my UFC sports betting model, I can show you my let's see, your data scraping, and we can see how I wrote basically a bunch of functions to scrape stuff. So it's to scrape cards, scrape dates, scrape fights, stuff like that. So all these are just put into little functions, and then what I do is I basically map these scraping functions. So I map these scraping functions, so it will scrape the cards, go through each list or each website link iteratively. So it'll go first through this website, then it'll scrape all this stuff, and then it'll go to the next link, scrape all this stuff, and then after that, I'll go and use the previous scraped stuff or scraped data, and then use that to scrape more stuff. So yeah, I think when you're thinking about like traversing nodes or just doing web scraping, mapping is a good way to kind of organize your thought process, and also organize how you're going to approach things too. Plus, it makes it a little bit cleaner. So instead of having all this stuff, we can see how this, which scrapes every UFC fight from every card, and all the data, it looks pretty clean because it's only about 4 functions. So it's pretty nice like that. I'm going to also show you a few useful things that come not with Purrr, but is useful when you're actually using Purrr. So what we can load in is the progress package. And a lot of times when you're running a long function, specifically a function that takes more than 10 minutes, where you're not really sure what's going to happen, it's nice to see some progress with it. With this, when I was scraping it, it would actually take about 20 minutes when I was scraping all the cards initially. Now, since I have a little filter where I'm only going to scrape cards I haven't scraped before, it's a little bit faster. But a lot of times you might want a progress bar, especially if you're doing like simulations. So what we can do is use the progress package, which is made for map. And we basically say we want to create a progress bar, and that's PB. And then what we can say is like PB is like PB what is it? Uh progress bar, and then new, and then total is equal to whatever we want to do. So for me, I'll just do a basic example. So I'll say sim, and then I'll say I don't know. Um we'll just say tibble x is equal to seek.int 1 to 1000. So in this case, we're gonna say we're gonna have essentially we have to say how many iterations we're gonna be doing. So we have to say usually like n row or number of rows that we're going to simulate through. In this case, now we can just say we would have to write a helper function. So for me, I'll just say I'll return. I'll just return, generic function, uh, function, and we'll say x, and we'll say x squared, right? So if we then do sim, and we'll say mutate x equals, and we'll say x equals a map x, and then we'll do generic function. We can see that it'll actually do that, but we never got a progress bar. So what we can do now is write in the progress bar in our generic function. So in this case, we have to say pb tick and sys dot sleep 1/100. Okay. And when we do that, we can see how this progress bar is going. It'll be like that. You may notice that this is actually slower right now because I'm using the sys.sleep. I mean, in reality, this is vectorized, so it's actually making it a little bit slower. But when you're doing like long scraping functions or long simulations, it's pretty useful to do that. So we can see that past that, and it was pretty useful. Additionally, what we can do is if you're writing, you know, if you notice that Purrr is a little bit slower than what you would like, you can also load in the Furrr package. So the Furrr package, Furrr package, let me show you guys the Furrr package. Is basically Purrr but with parallel processing. And there's a lot of things that goes along with Furrr that you kind of have to think about. But generally, if you're doing a lot of quick processes, it's generally useful to use parallel processing because it'll obviously go faster. But if you're carrying large data frames around, large model objects, it actually will be a little bit slower because it can't really handle all that in memory. So for me, generally I'll try using Furrr, but if I'm also doing like stand models or moving like millions and millions of rows through this iteration or through this simulation, then I'll probably navigate away from Future Map or from the Furrr package and stick with the original Purrr package. Okay. So one thing you have to do is you have to type in I believe you have to say your total workers. So in this case, we'll do like 4 since I think I have a parallel processing with 4 cores. And what we'll do is I'll just do a simple one with 1 1 2 3 1 2 3 1 2 3, right? And we can say is and we'll say generic function we'll say parallel function, and we'll give it sim, and we'll give it the square root of sim. Yep. So I'll just kind of benchmark it because I'm actually kind of curious about it. So sys dot time, and then what we'll do is we'll just do the first simulation. So we'll say sim mutate sim map parallel function, and then end begin minus sys dot time. Oops, and we'll pass that with sim. Right. And what's kind of funny about and 2, what's interesting about Um, the Furrr package, right, is that it's simply changing map to future map. Actually, you should not have put that many zeros in. I'm gonna um do like 1, 2, 3, 2, 3. Um, yeah, can I stop that? Oops. Yeah, because I put way too many zeros. That was a misclick. And I'll say this to tidy Tuesday per Tuesday. Okay. Yeah, so we actually don't want to do like that many. Okay. Let's see what else can I do while this runs a little bit. Um, and then I can oh yeah, I can show also the other function with handling errors using the possibly function. So with Purrr, there's actually a bunch of like helper functions that can do some error handling too. So if we go back here, and if we go to our reference, make sure this is going down. Okay. We can see that there's some interesting where is it right here. So basically it'll capture some side effects. In this case, usually what I'll do is use the possibly function. There's three main functions: safely, quietly, and possibly. um Safely is pretty good. Generally return like a bunch of two lists, like one with the value and one with the return to error message. And then possibly we'll kind of do the same thing, uh, but it'll force like a default value. Okay, let's see here. Okay, maybe I shouldn't have done this. um, I should have just done that. I don't know why I did that. Let's see if I can stop this. Okay. No, don't terminate. I should probably save it just in case it crashes. Generally, I try to, when I use parallel processing, I do it for more of a statistical simulations, not really for like these little general square root things. Um, and also I don't do that many simulations with it. So generally, it's a pretty long process already. So I try to stick with 100, like when I'm like bootstrapping or something like that. So I would be a little bit wary with parallel processing just because for me personally, it causes issues with R. Um, so let's see if I can get to this. Okay, you know what? Okay, get out of here. Oh, okay, it's gonna probably crash, I guess. Okay, just okay. I'm just gonna reopen this. We'll do Tuesday per. Okay. Oop. Okay, there we go. And I'll just do it there. And I'll just load in the stuff. Sorry about that. Okay. So we have that, and then what we can do is I'll just do the 1,000 right there, and then we can see how what's it called, and we have the exact process and it's a little bit faster. Okay. Oh, okay. So one thing that we can do with per is we can show the possibly and safely. In this case, I'll probably just do the possibly. So in this case, I'll just do seek dot int and we'll say minus minus 100 minus 1 to 5, right? And we'll say x. So if we wanted to take like the log of this, we could say, mutate logged equal to map x, and we'll say log, and it'll probably return a error, right? And so what we can do is also do a possibly, and then we'll possibly, and then we'll say log. Otherwise, we'll just say like a 0 or something like that. Maybe this isn't right, the best example, but maybe we can do a square root of like one. I'll do that. But you can do some error handling too. So let me see. There's a good example where safely log. Oh, okay. That we'll just do that. Find rows, and we'll say x tibble x equals a. Oh. Safely, and then we'll say log a 0. Otherwise, oops, or possibly. Does this actually work anymore? Let's see here. Okay, it kind of does. So yeah, you can see how we can do some error handling and stuff like that, but I personally don't use it a lot. So again, it's not too useful. I only use it mostly when I'm doing a bunch of web scraping. In that case, they usually pass in a decent amount of errors. When there's like a missing link that just so happens to be like a dead link or something like that. So yeah, let me see. I thought I could get possibly to work because that. Okay. I guess. Oh, I guess I didn't pass it in as a list. So that's how you do it. So with that being said, I hope you guys enjoyed the video. I know this is pretty quick, and I went pretty high level on over the functions, but once you get used to Purrr and its framework and writing functions, I think it's probably one of the more useful packages that is underutilized and beginner data workflows. So that's the conclusion to the Tidyverse series. For my next series, I'm going to be focusing more on our Shiny stuff. So I want to go over our Shiny filtering, our Shiny charts in general, how to do files and stuff like that. So that'll be an interesting project, an interesting series. So I'll see you guys next time, and tidy on.